Today, I'm going to look at various ways to get to space. One of the original ideas was to use a cannon as in Newton's cannonball. The idea was that if you shot someone out of a cannon with a high enough acceleration, they would have a high enough velocity to orbit the Earth. Now admittedly, this wasn't an actually proposed method, but rather a thought experiment to visualize gravity. Besides, the g-forces necessary to get you to orbital velocities with a cannon would be on the order of 1,000, which is death. However, a similar idea to this, known as a space gun, has actually been looked into. It would work essentially the same way, with a chemical propellant accelerating a payload into orbit. However, the g-forces would still be too large for humans, or even some of the more delicate equipment, to survive. As such, only freight could be sent up this way. Furthermore, a burn would be necessary once in orbit to avoid entering the atmosphere again and hitting the spot the payload was launched from. There are variations on the space gun, such as the ram accelerator. This accelerates a projectile through a tube filled with a special combustible gas. The projectile, containing a ramjet, compresses and ignites the mixture, accelerating the projectile to orbital velocities. Another variation includes the mass driver. This uses electromagnetic forces to accelerate a projectile, as opposed to the chemical explosion in the space gun. The mass driver, like the ram accelerator, has the advantage that it can be accelerated over a longer distance, so the g-forces won't be nearly as high and potentially fit for humans. Lastly, we have the star tram and launch loop, which also use electromagnetic forces, in this case a maglev track, to accelerate a payload into orbit. The difference is that the star tram, like all previous iterations, is based on the ground, while the launch loop is suspended in the air with supports. Again, these can be accelerated over a longer distance, so the g-forces are potentially human survivable. However, for all of these variations, an in-orbit correction burn is needed so the craft doesn't crash back into the launch point. This is just a property of orbital mechanics. Staying on the idea of structures getting us into space, we have the space elevator. The space elevator is essentially a long cable anchored at the equator and off in space. Since modern traditional materials are not nearly strong enough to support a structure that goes all the way into space, the elevator has to be anchored in space. This is done by attaching a counterweight at the space end of the elevator, so the center of mass is at geostationary orbit. Geostationary orbit being the point where the orbital velocity is the same speed as the rotation of the Earth. As such, the center of mass appears to remain motionless above the sky, meaning the rotation caused by the Earth is enough to keep the elevator cable taut. Then a payload is brought up to space by traveling along the elevator. A variation of this is the orbital ring, which is just a standard space elevator with a ring, moving at orbital velocity, attached at the space end. This ring is designed to support a type of maglev train, which allows fast travel around the space above Earth. Another variation is the space fountain, which is like the space elevator, except instead of using the tensile forces caused by centripetal acceleration, it is more just a type of tower. It supports itself by sending up pellets, which are redirected back down at the top of the tower. The force of this redirection is what keeps the tower standing. The last variation of the space elevator is the skyhook. The skyhook is not actually attached to the ground, it is just a segment of cable put into orbit. There are two types, rotating and non-rotating. In both cases, the payload is brought part of the way to space, where the lower end of the space hook attaches to the payload and brings it the rest of the way up. The difference between the rotating and non-rotating types is that the rotating swings the lower end into space due to its rotation, while the non-rotating type just uses a climbing method similar to that of the space elevator. The skyhook is actually a subgroup of the larger set of space tethers, which are cables that can be used for propulsion or maintaining distances between objects, among other things. The skyhook, however, is the only space tether that can help us get into space, so it is the only one that I will look at here. Another method for getting to space is to use beam to power. This involves sending a beam of energy to a craft. One type of beamed power involves solar sails, which get their thrust from pressure due to light. Yes, light can in fact apply pressure. Another type of this involves thermal engines, where the energy beam superheats propellant, igniting it and creating thrust. This can be more efficient than the standard chemical reactions, which I will look at in a bit. A specific type of this beamed power is laser propulsion, which simply uses lasers to beam the power, as opposed to the other type, which uses a beam of microwaves. Moving away from structure-based space launches, we have orbital airships. These use buoyancy and high-efficiency, but low-thrust rockets to obtain both orbital heights and velocities. Early versions of this type have already been used, such as the balloon Felix Baumgartner used to get to the stratosphere. However, with the orbital airship, an atmosphere is necessary, so while it would be fine for Earth, it cannot work on the Moon, for example. All of the other examples would actually work better without an atmosphere. Now we have chemical rockets, which is the only one of the examples so far that has actually gotten things to space. These use a chemical reaction, often between liquid hydrogen and oxygen, to rapidly accelerate gas particles out the back of the rocket, producing thrust. The very cold liquid fuel and oxidizer is actually run throughout the engine to help prevent overheating before being combusted and shot out the end of the rocket. It is actually believed that we have gotten as efficient as we can possibly get with this type of chemical propulsion. As such, due to the fairly high costs associated with launching these chemical rockets, the other methods are being looked into. Lastly, we have my personal favorite way to get to space: spaceplanes. A spaceplane is just a craft that works both as an aircraft and a spacecraft. They all have wings, or some other way of generating lift, and rocket engines. Some types have air-breathing engines as well, in order to create thrust in atmosphere. All 5 working designs of spaceplanes that exist are rocket gliders, and as such use an unpowered glide to return from space. The space shuttle was actually a spaceplane, despite using a rocket to get into space in the first place. The space shuttle used rocket engines to propel itself in orbit, and would use its wings to glide back to Earth. A variation on spaceplanes is the air launch. An air launch involves using a standard, air-breathing plane to bring a payload up most of the way to space, when the payload detaches and uses the rockets to launch itself the rest of the way up. This method is currently used by Virgin Galactic in both their Spaceship One and Spaceship Two. This type has the advantage of still using the highly efficient air-breathing engines to get most of the way to orbit, while not having to bring many of the heavy aircraft features actually into space, where they are useless. Unfortunately, a spaceplane, which can take off from a one-way, get into space, and land, which is my specific favorite idea for getting to space, does not yet exist. However, a Sabre engine, which combines the air-breathing and rocket engines, is currently being developed, which could save on weight for a spaceplane, and could lead to this last type. Nevertheless, hope you enjoyed it, hope you learned something, and see ya!